Um, Hi everyone, and this is Let's Discuss paper right after reading it. So in this journal club, we selected and started reading a paper 2 hours ago, and we are going to start discussion now. We have two people today, me and Chan Shen. Chan Shen, can you introduce yourself?
Okay. Hello everyone. My name is Qian Chen, and I'm currently a PhD student at Monash University, Australia.
Thank you, Chan Shen. And me, Yota Kawashima. I'm a research engineer in Japan. Okay, so today we're going to discuss a paper entitled Waves Traveling Over a Map of Visual Space Can Ignite Short-Term Predictions of Sensory Input by Benigno et al., 2023, Nature Communications. And before the discussion, I will quickly give you a summary of this paper. And after that, we're going to start the discussion. Okay. So this paper is about deep learning, basically, or neural networks. So in neural networks, the feed-forward and feedback, models is being predominantly used for various, purposes. But we know that in the visual system, we have more or a lot of horizontal recurrent connections. So this paper tried to kind of investigate what the horizontal recurrent connections do. So previous research shows that this horizontal recurrent connections can generate waves of neural activities across visual systems. The authors hypothesized that maybe these waves of neural activities can be used, or the visual system use the waves of neural activity to share the information across different local areas, again, within the visual system. And in order to test that, the authors of this paper developed a neural network model with recurrent connections, and then try to answer what the recurrent neural network can do. So basically, what first they found is that they used two both simple naturalistic image to test the neural model, but I'm gonna first talk about only the result from the data when they also they use the simple images. So to answer the questions, and again, the hypothesis was that the wave of neural activities propagate by the recurrent neural network, recurrent connections. And then actually they observed that when they present an image, just a single point in a kind of black background, when they feed that image to a neural network with recurrent connection, that generate the kind of propagation of waves across the layers. But without recurrent network, it didn't work. And also by decoding the activities of the layers, recurrent connections layer, they can predict the time and location of the dot in the image. So they kind of conclude that this recurrent connections is important, and again can generate waves of activities which can use to share the information across local areas within the same layer. That's kind of, I guess, the key part of this paper. And they also try to kind of reconstruct the image from the, or not reconstruct in a sense, this paper kind of tried to test whether the neural activities, the neural network models can predict the next time frame given the current time frame or image frame. And then they did that for the simple image and also naturalistic scene image, and they successfully, or the model could successfully predict the next time frame given the current time frame or image frame. And here they investigate what are the important factors in this model, and then they found the ratio between the recurrent network and other feed-forward network connections is important. So if the recurrent connections are too strong, it's not good. And also if the recurrent connection is too weak, that's also not good. So basically the balance is almost like the one-to-one between recurrent and feed-forward is the optimal. And also this extent of recurrent connection. So when we think about recurrent connections, we can think about the really, the connection that cover huge spatial range, but also we can think about just only, small range of spatial locations. Basically, this paper says that it highly depends on the optimum, extent of recurrent connections is dependent on the inputs. So depending on the spatial, information of the input, the optimum recurrent connection, the extent of recurrent connections is determined. And I think, yeah, that's almost it from my summary. Of course, they investigate other stuff, but I just didn't include that part in our or in my summary for the sake of time. So, Chanshen, do you want to add something?
Yes, I would like to add something that I found very interesting in the paper regarding the frame prediction part of the study. So in this part, they used dynamic, naturalistic stimuli, which are basically movies of people walking, just doing this.
Yeah.
And what they did was they feed first half of the movie into the model, and then they asked the model to predict the second half. And what they found was the network with recurrent connections, with optimal recurrent connections, can predict up to 100 frames into the future. Whereas the feed-forward network cannot do that, and networks with too high proportion or too low proportion of recurrent strength also do not perform well, as their prediction accuracy drops a few frames or a few seconds, like shortly after the first half of the movie, offset. And another thing is what they found was this network is very flexible, as it can flexibly change the outputs they predict if you switch the inputs between few movies that it has learned. So if you switch from a man to a woman walking, then its prediction will also switch to a woman walking, kind of. So yeah, that's the part I wanted to add.
I see. Yeah, to be honest, I'm not sure about the second comment or the finding you mentioned, the switching part. The reason is related to kind of my comments. So one of their finding is that this extent or the size of coverage of recurrent networks depends on the input image. So when I read this part, then I felt like, okay, then how many, not layers, but I don't know how to explain it, but in a sense, it says that as our experience or our visual or field or vision has many scales, spatial scales. So that means that we have many spatial scales. We should have a many different coverage of recurrent connections in the not maybe same layer but in different layers. But if so, then how many layers is necessary or something? Does it make sense? So
yes. So if in a sense, if you let's consider the simple case where they only have one layers for spatial scales, then that means when the model is optimized in terms of spatial scales of recurrent strength for predicting one movie, then it will not be optimal for predicting the other. That means they need multiple layers with different spatial scale tuning to flexibly predict different movies.
So coming back to your the second point about the switching, I am not well, I couldn't truly understand the method they used here, but from the figure, you mentioned that the two movies are woman walking and man walking, right? And it seems like they first train the model, or they had two models first in a sense, and then train separately. I mean, train these two models separately using different movies, man walking and woman walking. So we have first that, and then after that, they kind of combine them. When I say combine, I think they introduce some, weight, like considering the woman walking, the parameter from woman walking versus the man parameter from one man walking. So by changing this weight, you can, or the model, consider the weight from woman much higher than the man walking. So this weight, by changing the weight, we can switch like the
It mentioned that this prediction loop is a closed loop forecast, which basically means the network adjusts itself based on its output in a sense. So maybe in the process of doing so, when you switch the input, and then in the process of doing so, it would try to tune the model better and better to update its prediction based on the new inputs.
Yeah, so my kind of question is like, or at least they mentioned that, when they randomize the order within the same image, I mean, the order of frames in the same image, it just did not work well in their model. That's another finding from from the paper. So it kind of, I don't know, but what I want to ask is that what's going to happen when we, use the completely new image, novel image or movies?
It's like let's say it's completely trained completely on woman, but
Yeah, exactly.
For men.
Yeah. Because here you mentioned the switching between man and woman, but they use the trained parameter from both image, and then check whether that can be, the parameter can be switched. Yeah. So yeah, I'm not sure what's gonna happen if the model receive a completely new image. And also, I wanted to maybe in the supplementary material or somewhere they talked about the extent of recurrent connections for the naturalistic image, but I want to see what kind of pattern they obtained from the naturalistic image. I understand it can be really complicated, not like a single this size or that size, but maybe mixture of weird shaped connectivity. But yeah, I just want to see that. So yeah, we kind of went into the discussion part, but yeah, that's kind of the questions or comment I had.
Okay.
Yeah.
So regarding your comment on training and testing on different videos,
Yeah.
I think they need larger data set to do that. They need larger set of videos. I actually don't know how many videos they use for this. What they show in the figures must just be an example of some sort. But if you consider, how our visual system actually works and the fact that it's able to generate accurate representation. Well, very dynamic and accurate representation of, random person we have never seen before just walking down the street smoothly. That's because we have a lot of input of seeing people walking, right? So similarly, if you want this kind of regime paradigm to work, then you need to feed a lot of videos into the movie in order to test whether it works on a new video.
Yeah.
Just by I don't know, just a small scale of switching between a few video is already allowing it to update prediction itself is a pretty cool finding.
Yeah. Yeah. Other comments, questions? Do you have any?
It's really probably related to what you said anyways. So I would think it would be interesting to see the behavior of this kind of model to more dynamic and unpredictable stimulus. So here what we see is just someone repeatedly doing this all the time, right? I would wonder how the system learn and update itself if the video incorporates more changes, unpredictable changes across time.
Unpredictable changes.
Like it's not like unpredictable changes. Let's say like somebody it's like Mario.
Yeah.
Sometimes it jumps and sometimes it
I see. Well, again, I'm not sure whether this jump action corresponds to the shuffling, but at least they try the shuffling the order of frames, and it did not work well.
Oh, so shuffling it makes the movement not smooth, so they're not connected to each other.
Yeah, Yeah, I think they mentioned something like that somewhere.
I see.
In the text, I don't know whether they had some, figure for that, but I'm sure that they mentioned something about that when they shuffle the, frames. The model did not work. So the movie has to be like maybe not smooth, but rather somehow, consistent from the previous frame. Yeah, so I have another kind of comments or questions. So whether this paper, was interesting. And they mentioned about the balance between the feed forward input and recurrent inputs. And then as this is the model, we can change the balance. So consider the more recurrent connection than the feed forward and the vice versa. And then we will have some, output from the model, right? For each, settings.
Each mix.
Yeah. And then if we can test that in the brain, I'm not sure whether it's possible or not, but, somehow, reconnect or maybe, I don't know, some...
In animals, it may be doable.
Yeah, animal or some, brain damaged people, some disorder or something. I don't know whether there's any kind of, brain disorder that, changes the ratio of the connections. But,
very selective, intervention, at the single neuron level. So it's not like TMS where you just like kind of disrupt whole bunch of neurons, whatever they're doing. You have to selectively disrupt like certain connections at the single neuron level, like single neuron synapse, right?
Yeah.
I'm not sure if we can do that at this stage.
Yeah. I understand it's, really difficult and it may not be possible to do that in the end. But, what I want to say is that, if we can, make the prediction based on this model and then see whether the prediction is consistent with what we are going to get from the brain, then, this finding is, robust. So
regarding in your summary, you said the optimal ratio is 1:1.
Yeah.
But in the intro, it says only 5%. Wait, hang on. 5% of synapses received by a neuron in the visual cortex arrive through feed-forward pathway.
Yeah.
And the rest is 95. So doesn't that mean it should be 5:95 instead of 1:1?
Yeah, but I don't know. So they mentioned something, their finding is almost consistent with the happening in the brain. Yeah, I remember that, in the introduction, they mentioned that, 5% of feed forward and then 90% of recurrent, as you mentioned, as you said. Yeah, that's what they mentioned in the... But I don't know. I may miss something important, but maybe it's not the amount of connections, but rather the strength of the connection.
Right. Yeah, that's what they said, the connection strength.
Yeah.
And also in the intro, they said, while the feed-forward synapses are strong, meaning that, they may only compose of 5%. They have, signal strength-wise, they can reach a much higher percentage.
Yeah. And also now I, realized I'm sure that this, figure is just for illustration and may not, correctly capture what they did in the network, in their model. But you mentioned that the feed forward 5%, recurrent 80%. So does this model consider that or not? If so, I mean, yeah, I'm not sure.
Yeah, also I'm not sure because I didn't read the methods in detail.
Yeah, method detail. But the point is that, if we consider these recurrent connections, it's gonna increase the number of connections, like exponentially this much. So it's gonna take time to train the model as the connection from, I don't know, even like a 4 nodes network, the connection can be really, the number of recurring connection can be really huge.
Yeah.
So not sure how long it's gonna take on. Yeah, but yeah, anyway, that's the number of connection, not the strength of activity. Not strength of connection. So yeah, first. Anything else? I think, ask all the question I had and made all comments.
Yeah, I also don't have anything else.
Okay, then, let's finish the discussion now.
Okay.
See you next week. Bye bye.